Good day, everybody. This is Dr. Nandi back again. Today I'm going to talk about a problem on Kruskal-Wallis test. So I will share my screen with you. So it's a non-parametric test to compare the medians of more than 2 samples coming from more than 2 populations. So the problem is, assume the following samples came from populations which are not approximately normal. At alpha equal to 0.05, test the null hypothesis. The medians of the 3 populations are the same. Against the alternate hypothesis, at least one of the population medians is different. So we have the 3 samples, A, B, and C. Okay, and we then rank them together. The lowest sample is in sample B. It's number 401, its rank is 1. Then the next one is 403, in sample A, rank is 2. The next one is 423 in sample C, its rank is 3. And we continue in this way till we exhaust all the samples, okay, and give them ranks. Then we find the sum of the ranks for each sample. So sum of the ranks of sample A is 32, for sample B it is 36, and for sample C it is 52. Now we need to calculate the test statistic, which is given by this formula, 12 divided by n times n plus 1. The whole thing is multiplied by sum of R1 square plus divided by N1 plus sum of R2 square divided by N2 plus sum of R3 square divided by N3 minus 3 times N plus 1. N is your total sample size. Here N is 15. And N1, N2, and N3 are all the same, equal to 5. So the finally boils down to H is equal to 12 divided by 15 multiplied by 15 plus 1 is 16. And then the whole thing is multiplied by sum in the parenthesis, 32 square plus 36 square plus 52 square divided by 5 minus 3 times 15 plus 1, or 16, 3 times 16 is 48. So the test statistic H works out as 2.24. Now our null hypothesis is M1 equal to M2 equal to M3, where M is the median. And alternate at least one of the, not the mu's, it should be M's is different. So test statistic is 2.24. Degrees of freedom is K minus 1. K is the number of populations being compared, which is 3. 3 minus 1 is 2. So we need to find the p-value. The p-value is the area to the right of the test statistic under the chi-square curve with degrees of freedom 2. So we go to second verse and scroll down to chi-square CDF in TI-84. Our lower is, we start from 2.24. Upper is a very large number on the right, which is 1. Then second comma gives me capital E, which stands for exponent. And then I type 99. This means 1 exponent 99, or 10 followed, or 1 followed by 99 zeros, which is a large number. Degrees of freedom is 2, and then we paste, enter and enter. And chi-square CDF works out as 0.326, which is the p-value. Notice this p-value is greater than alpha equal to 0.05. Therefore, the decision is failed to reject H0, and the conclusion is at alpha equal to 0.05. There is not enough evidence to support HA. Okay, so I'll stop here today. If you have any question, please write me a comment and I'll reply to you as soon as possible. Thanks for watching. Have a great day, and please subscribe to my channel because I come back every week with new problems. Take care and see you next time.